This is Zhen from Group 9, and our members are Benjamin, Callista, and Thai. And today, we Group 9 are going to present about diabetes analysis and prediction. So what is exactly diabetes? So diabetes is a chronic disease that affects our body health, and it will cause some serious damage to our body parts, such as hearts, blood vessels, eyes, kidneys, and nerves. And it usually will occur when we are having a high level of sugar in our blood, or the inability of the pancreas to produce insulin or to use insulin properly. And the reason why we pick this is that we found out, according to WHO organization, as well as the World Health Organization research statements, there are about 402 million of people suffering the diabetes, and it is still rising nowadays. And there are estimated 1.5 million of deaths because of diabetes. So our objective of this is to analyze our dataset with different methods and machine learning models to predict whether the patient has diabetes, or to comparing which statistics or machine learning models has the highest accuracy among them. And here is our literature review, which our taxonomy mapping, and we have categorized them into 6 parts, which are objective, data source, features, statistical model, machine learning model, and results. Sorry about that. Yeah, this is all for our taxonomy mapping, and next I'll pass on the presentation to our next speaker.
My name is Callista, and I will be explaining the data and methods part. So for the data parts, the Pima Indians diabetes dataset was obtained from Kegel. The original dataset was collected from Pima Indian females who live near Phoenix City, Arizona. It was originally published by the National Institute of Diabetes and Digestive and Kidney Disease. The dataset consists of 796 rows and 9 columns of variables, with 8 independent variables, which are pregnancies, glucose, blood pressure, insulin, BMI, age, skin thickness, and diabetes pedigree function, and 1 dependent variable, which is outcome. There are 3 methods, which are EDA, statistical, and machine learning. The first one is EDA methods. First, handling missing values. We handle them by replacing it with mean. And second, handling outliers. We handle them by removing data entry error. Next, encoding. In the encoding step, we encode the numerical value into factors. Next, data normalization. We normalize the data to a range between 0 to 1. Lastly, trend test split. We split the dataset into 80% trend set and 20% test set. Statistical methods, we search for the mean, median, mode, quartiles, skewness, kurtosis, standard deviation, probability of its independent variables in the dataset. For machine learning methods, we perform 4 machine learning algorithms, which are logistic regression, random forest, decision tree, and support vector machine. The accuracy of each of the machine learning algorithms will be explained in the next part by my friend.
As you can see, this is the statistical summary of our dataset. We initially had to reduce the dataset from 768 rows to 659 rows. This is because of outliers and missing values. According to the results, the top 3 variables that affects the outcome is glucose level, BMI level, and age. We have used multiple comparison models and techniques to find which has the highest accuracy algorithm. After testing, we found out that the highest accuracy algorithm is the logistics regression with an accuracy of 80.3%. Following that, close behind is the decision tree post-pruning and the SVM algorithm, both at 78.03% accuracy. Moving on to the limitations and future studies. The first limitation was that the dataset was too specific. The dataset we used only targeted females of Pima Indian heritage. Plus, there also could be more factors such as lifestyle, diet, and work life of the candidates that would overall affect the outcome whether they are diagnosed with diabetes or not. They were also missing values from the current dataset, causing to lower the accuracy of the model. So for future studies, having a dataset that is complete and targeted worldwide could lead to better analysis and higher accuracy. Besides that, we could use more machine learning or statistical methods to better understand the dataset itself. In conclusion, we constructed 4 prediction models and found out that the highest accuracy is the logistic regression model with 80.3% accuracy. We also found out that the only dependent variable is the outcome, and all the other variables are independent variables. From the statistical analysis method that we applied, we gained a lot of information and insights that help with the data EDA and the data pre-processing. Thank you.